In this tutorial, you will learn how to use the HC SR04 ultrasonic sensor. It can measure distance from 2 centimeters to 4 meters with a ranging accuracy up to 3 millimeters. The working principle of this module is quite simple. It emits an ultrasound at 40,000 Hz, which travels through the air, and if there is an object or obstacle on its path, it will bounce back to the module. Considering the travel time and the speed of the sound, you can calculate the distance. The module has 4 pins: ground, VCC, trig and echo. The ground and the VCC pins of the module needs to be connected to the ground and the 5 volts pin on the Arduino board respectively, and the trig and echo pins to any digital input-output pin on the Arduino board. In order to generate the ultrasound, you need to set the trig on a high state for 10 seconds. That will send out an 8-cycle sonic burst, which will travel at the speed of sound, and it will be received in the echo pin. The echo pin will output the time in microseconds the sound wave traveled. So, for example, if the object is 10 centimeters away from the sensor and the speed of sound is 340 meters per second or 0.034 centimeters per microsecond, the sound wave will need to travel about 294 microseconds. But what you will get from the echo pin will be double that number, because the sound wave needs to travel forward and bounce backward. So in order to get the distance in centimeters, we need to multiply the received travel time value from the echo pin by 0.034 and divide it by 2. Okay, now let's make the code. Here's an example code for this tutorial. First, we have to define the trig and the echo pins. In this case, they are the pins number 9 and 10 on the Arduino board, and they are named trig pin and echo pin. Then we need a long variable. I will name it duration for the travel time that we will get from the sensor, and an integer variable for the distance. In the setup, we have to define the trig pin as an output and the echo pin as an input, and also start the serial communication for showing the results on the serial monitor. In the loop, first we have to make sure that the trig pin is clear, so we will set that pin on a low state for just 2 microseconds. Now, for generating the ultrasound wave, we have to set the trig pin on a high state for 10 microseconds, and we will do that with these 3 lines here. Now, using the pulse in function, we will read the travel time and put that value into the variable duration. This function has 2 parameters. The first one is the name of the echo pin, and for the second one we write either high or low. In our case, high means that the pulse-in function will wait for the pin to go high caused by the bounce sound wave, and it will start timing. Then it will wait for the pin to go low when the sound wave will end, which will stop the timing. At the end, the function will return the length of the pulse in microseconds. Now, for getting the distance, we will multiply the duration by 0.034 and divide it by 2, as we explained this equation previously. At the end, we will print the value of the distance on the serial monitor. What we will get as a result should look something like this.